This conference will now be recorded.
Yeah, we'll start with a digital design subject. I used to deal with this digital design. So before going to the subject, we'll discuss first what are the topics that I am going to do in this, going to deal in this subject. Yeah, yeah. Mostly the first one will be number systems and conversions. Conversions of just 1 minute. I'm getting a call.
This conference will now be recorded.
Yes. Yeah. Uh, so in this digital design subject, these are the topics that we are going to discuss in the coming days. So let's list them all. What are the topics? So number systems and it converts in conversions from one number system to another number system, and then logic gates, and then realization of logic gates. So this will be in two ways, like using universal gates and muxes. I'll take an example for this as 2 into 1 mux. And next, full adders and half adders, which is nothing but adders. And this is also, we'll also discuss with how to realize this full adder and half adder using universal gates and muxes and multiplexer. Mux is nothing but multiplexer. And next, we'll discuss briefly about multiplexers and demultiplexers. And after, we'll go for decoders and encoders. And after this, when we are dealing with decoder and encoder, and again we'll also discuss about how to realize this decoders using uh, gates and also with using muxes. Okay. And next, a map. In this K-map only, that we'll also discuss min terms and max terms. After that, we will also discuss about comparators. And in these only, we'll have many topics to discuss. Like suppose if I tell them in terms and max terms means, again we'll also try to realize different structures like some gates or some muxes. So many things will be there inside this all. So then comparators. So till until the comparators, then we have done the combinational circuits. So then after we'll go with sequential. sequential circuits. Okay. While coming to sequential circuits, first we will discuss about flip-flop. Okay, and how many types of flip-flops are there? Okay, and then after latch and flip-flops, latch and flip-flop, and then conversions of flip-flops. Okay, and then later on we'll discuss with counters, and then we'll discuss it. Many things will come in between, and don't worry about that. FSM, finite state missions. Okay, so many topics will be covered in between here only. Uh, so no need to be worried. FSM means again here in the FSM you'll also be dealing with More and Melee FSM. Make it this and it's not 7. Make it and okay. Melee FSM. So these are the main topics. Some of the topics that I have didn't written. While going only, we'll be deal with those. Means while when we are discussing, those things also will cover. So what are things are left? Yeah. So this is the main topics that I have written. So every day that we used to in the starting 5 minutes, we'll discuss like what are the topics that going to deal on that day. And if you have any doubts, you can ask me on end of the class or mm, starting of the class or in between anywhere. That's not an issue. You can stop me anywhere and you can ask me. That's not a problem. Okay. Now, today we'll try to cover at least up to logic gates. Okay, number systems, conversions, and logic gates. We'll try to cover it. Let's see. Okay, I'm opening a new page. Yeah, if you want this page, you can ask me. I can bring back this page. Okay, let's see. Number number systems. If you don't understand my writing, please ask me because I'm writing with mouse. So it might be possible like numbers will not be sorry, letters will not be a perfect. Okay, so basically, yeah, that's everyone came. Okay, so number systems that basically that we have four types of number systems in the digital design. First one will be decimal number system. Decimal number system. Okay, decimal number system. So in this number systems, like how many numbers does we have? That means in order to form a decimal number, how many numbers we required? So we required 0 to 9 numbers. That means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the numbers that we have here to define any number in the decimal system. Like for suppose if I define this 256, okay, so where this is a decimal number system, okay, so in order to identify that which number system, so we need to indicate a base. What is the base of that particular number system? Suppose how to define a base means, if we have numbers, how many? 0 to 9, that means 10 numbers. So using 10 numbers we used to define a number system. That's why the base will be having 10. So base is 10. That means we used to define with 0 to 9. So 0 to 9, if you count, we will have 10 numbers. So this is the indication of any decimal number, any decimal number. Okay. And while coming to the next type, so one is decimal number system, and next one will be binary number system. Binary number system. Yeah, this is also like when I'm telling binary, then you generally knows that what numbers we'll have. We will have only 0 and 1, right? Using this, we used to define our binary number system. So 0 1 means like how you used to define. Suppose there is a number 1011. Okay. So, and what is
Base
the
2.
base? Yeah, 2 will be the base. Only two numbers we have. That's why 2 will be the base. Okay. So this will be an example of binary number system. And next number system will be an octal number system. Octal number system. Oh, this is the A. This is A octal. Okay. So here we have 0 to 7. That means 0, 1, 2, 3, 4, 5, 6, 7. Only these numbers that we can able to define in octal number system. So in order to form a number using this, yeah, you can see 26. So the base will be 0 to 7. That means how many numbers we have? 8 numbers.
8.
So the base will be 8. And similarly, the other number systems we have hexadecimal. Hexadecimal. Hexadecimal number system. So here we have 0 to 15, only these numbers. And what are those numbers means? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and after 9, so it will be instead of 10, like you will write as A, B, C, D, E, and F. So how many numbers we have? 0 to 15 means 16 numbers. So an example I can written as 1C5. So this will be an hexadecimal number system, and most of the time this decimal, it can also be given as H instead of 16. Okay, instead of 16 H. Why? Because the 15 one is there, and the coming 16 will be H only, right? So most of the time, sometimes it will indicate like this in order to confuse you. So don't get confused there. Okay, so these are the main number system that we have. So one thing you observed in this, when you are having when you see an examples of this 256 1126. So when you saw this example, see, when coming to decimal, the base is 10. Okay, so the numbers what you define, this should be less than the base. Yeah, obviously the same thing we have discussed now. So whatever the base value we have, so you need to define a number system less than that base number. That means, if suppose if you see here octal number 268 base 8 is not valid. Why? Because we need to what numbers we have to use for octal, 0 to 7 only, not 8. Okay. Similarly here, if suppose if it is like 1H like that, it's like 16, it's wrong. So what you understand, whatever the base you denoted, it should not be, it should be less than of that. So you cannot define 8 in the octal number system. Why? Because we already know this, 0 to 7 only we can able to form the number. This is the one point when you need to remember. Why? Because if suppose sometimes you used to get like a random number, you'll get like say like this 125. So in order to tell you, like, in the worst case, what is the base? Suppose you have your base is x, you don't know the x. So if anyone asks like what is the base, what will be the base in the worst case, so I can tell this, my base will be greater than or equals to, how I need to decide the highest value among this 1 to 5. Among 1 to 5, which one is the highest number? 5 is the highest number. So plus 1. So 5 plus 1, so 6. So I will define like this whenever the case, in such case, if I got. Why? Because this is the worst case, right? That means after this, we won't have any other option. Like, why I gave 6? Because the below numbers, I can able to see the below numbers only up to 0 to 6. Sorry, 0 to 5. Right? So 0 to 5 means how many numbers? 6. So that's why I gave x equals to 6. The highest value among that numbers plus 1. See, simply telling, like, suppose if we have 2, 1, 7. So if we have this, the worst case, if you want to tell what is the base, so how you will tell the highest number? What is the highest number? 7 plus 1 means 8. So x will be greater than or equals to 8. Greater than or equals to 8. Is that clear? Is that clear? Okay. Now let's see. We will see conversions of the numbers. conversions. So these are 1 mark questions, I guess. So I guess like everyone came here like in point of placement wise. Okay, any of the thing, that's not a problem. So most of the things here, these you can expect as a 1 mark questions. The worst case are 2 marks. Decimal decimal number system means decimal, just now just I wrote a decimal to any number system, decimal to any number system. That means either it may be decimal to binary, or decimal to octal, or decimal to hexa. Any means like all three. Okay, let's take a decimal number system. 25.05. This is my decimal number system. Okay, and base will be 10. So first of all, I need to convert this into. I am thinking to convert this into binary. That's why I gave base 2. Okay, and now let's see. So here we have two terms. When you see a decimal number system, here you have two different kind of expressions. So one is a fractional and one is a normal one, right? 25 and 0.05. So this will be splitted as 25 plus 0.05. Okay, now I'll deal with 25 with another method, and this is I'll deal with this with another method. Like both have different methods to solve. First of all, I'm taking this value, and if you see here what how to convert means using a division method. 25 here, 25 here, and where you are converting, on which base? From decimal to binary I'm converting. So take the binary, look into the binary. What is the base is 2. So 2 you used to divide with 2. On which base you are converting? What is the base number system you are converting? And yeah, two ones and two twos, right? And one will be the remainder. Two twos, 4, right? So one will be the remainder. So you write remainder as it is, like this. Again 2, 6. So there is no remainder. So it is 0. And again 2 threes. No remainder, and again 0. And if you see here again 2 ones, and 1 will be the remainder. Okay. So you need to note down all the reminders in such a fashion from bottom to top. Bottom to top. That means first one, this will be the MSB bit. This is the MSB bit, and this will be the LSB bit. Simple. Write down this. Now 1 1 0 0 1. So if I write from bottom to top, 1 1 0 0 1. This is clear. Just it is of base number, base 2 number. Okay. And what about this expression, fractional one? So I'll bring it to here. This will be dealing with using multiplication method. Yeah. Into which number I used to multiply it with the with the base of my destination number system, means where on which number system I'm converting that particular base. So I'm converting to binary, so the base with 2. Yeah. Tell me the value. What is the 0.05 into 2? Yeah. Anyone? Yeah. Point 1. And again point 1 into 2. So this will be the point 2. Point 2 into 2. So it will be point 4. Point 4 into 2. Point 8 and point 8 into 2. 1.6. Right? So like this, how many times like I'm going to do until unless you got the same number. I'll tell you what the same number means. Yeah. See, before that, see, when you are going for next multiplication, don't consider the value of this one. Only consider the fraction. That means again zero point 0.6 into 2. So what is this will be 1.2. And again zero point 0.2 into 2. Why I took zero point 0.2? I am not considering this one. Okay. So again it is zero point 0.4. And if you see again the same story. Here it is zero point 0.4 and here it is again it started with zero point 0.4. So I will consider only up to here. So until unless like if you got the same numbers, then you can leave it off. Like suppose 0 0 0 1 0, we are getting like this 1 0 1 0 1 0 like this. Any times if you do, you are getting the same number. So leave the 1 0, all 1 zeros, round off with only single 1 0, like that. And how to write here from the top to bottom. So that means this will be MSB bit. This particular one will be LSB bit. So now write it down here. So what is the final number will be 110001 point. Yeah, what is this? 000, 4 zeros and double. 4 zeros. So like this, you need to write with complete number using a binary. Like this, you need to convert. Yeah, same way. Please try to do it. Do it with octal. Means I want same number 25.05. Convert this number into octal. Same procedure. Only changes you need to change your base. Yeah, please tell me. I need a direct number. Yeah, please do it by yourself. I am not going to do. I'll wait for 1 2 minutes. Yeah. Can anyone tell octal number what is that? Yeah, I am doing. So base will be 8. Now tell me. Threes. 8 threes, 24, right? And remainder will be 1. So this is gone. I'll write like this. So that number will be 31. Okay. And what about 0.05? Multiply with 8. Yeah, please tell me this. Anyone who complete? Okay, okay. 31.0. Yeah, that's fine. That's correct. Yeah, that's correct. Yeah, those who done with, please tell about mm, hexadecimal. Convert into hexa and tell me. So what is this final number? Into 8 will be common. Let's deal with this. 0.05 into 8 will be 0.4. And next, again 0.4 into 8 will be 3.2. And again zero point 0.2 into 8 will be 1.6. And again zero point 0.6 into 8, 4.8. Where it is round off? I guess so many guys. It's 1.6, okay. And again zero point 0.8 into 8. So which will be 64, right? So which is nothing but 6.4. So till here it will be rounding off. So this number will be 0, 3, 1, 4, 6. Okay. Yeah. Okay. Now let's see. Please do it with this. Convert into the again 25.05. Convert this into 16, which is nothing but base 16. Yeah, tell me the fast.
19.
Okay, 19 point.
0C.
19.0C. Is this correct? Yeah, everyone got the same? Yes, yes. Only three. Yeah, 19.0C. Okay, okay. Okay, okay, okay. Okay. Chalo. Now, okay. This is the way that you need to do with any conversion from decimal to any conversion. Now let's see any of the number system to decimal means any number system to you need to do convert into the decimal number system. So let's see. I'm taking a binary number system. Okay. Suppose 1100.1101. So this is a binary number system. So I need to convert this into the decimal. So what is the base? 10 here. Okay. Now let's see. First, again the same. Split this into two parts. So first part I'm taking 1100. So if you are capable to understand directly, you can also write here 1101. I'm writing complete one. I'm not splitting the two parts. Okay. So before the decimal, you should multiply with this particular digit 0 with with base of that particular number. So every time this LSB bit will be the base power 0. This particular LSB bit will be the base power 01. Okay. Plus again this particular 0 you need to multiply with 2 power 1. Okay. And again the 1 you used to multiply with 2 power 2. So like that, so on. So you need to come from the LSB bit here like that. How I came 2 power 3. So that 0, 1, 2, 3, 4, so on like that. So on which you need to use these powers? On the base of that particular number. So here my base number is 2. That's why I am using 2. And similarly after decimal, so this 1, you need to go like this, in this way, right? Like how you go in this way, you need to go in this way. So 1 should multiplied with 2 power minus 1 digit plus and so on here. Again 1 into 2 power minus 2. This is 2, okay? Yeah. Plus 0 into 2 power minus 3 plus 1 into 2 power minus 4. Yeah, please do the multiplication and addition. These all you all know this. So 2 power 0 will be 0 plus this and again 0 into multiply with anything, it's 0, and this will be 4 and this will be 8 point. Yeah, please tell me this, what is this? Nothing but 1 by 2 plus 1 by 4 plus 0 plus 1 by 16. Yeah, Tell me the final number.
12.8125.
What is this?
12.8125.
8125. Yeah, so like this you need to convert. Yeah, now please do it fast for this another numbers I'm giving. Yeah, similarly you need to go with any other number. So I'm giving example an octal number of 26.128 convert into decimal 10, and here 1AF 16 convert into decimal. Yeah, please tell me the direct answers. I am going to write here. Yeah,
18.75.
18.75 of this one. 18.75. Okay.
Sir, I got 22.156. Sir.
Okay. 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 We'll
Yeah,
do that. Don't worry.
26.12 octal to decimal is like
Okay.
22.15.
Okay. Okay. Let's see. We'll discuss. We'll do that. Don't worry.
And how about this hexa to decimal? So like I think we should convert it to binary first. Is it?
No, same procedure. Any two decimal, the same procedure. Hexa to decimal also.
Okay.
Same f into 16 power 0. Same procedure. No issue. Okay. Let's see. Someone got this. We will clarify here. What is that number is 26.12. Okay, I'm doing here 26.12. Okay, 6 into, so what is the base of this? 8 power 0 plus 2 into 8 power 1. Okay, so after decimal, yeah, you can see here, what is this? 1 into 8 power minus 1 plus 2 into 8 power minus 2. Simple. Yeah, tell me now. Yeah, tell me. Simple.
22.156. Sir.
Yeah, 22 point, and this will be 1 by 8 plus 2 by 64. So this will be 1, 5, 6, 2, 5. The complete number. And someone told 18.75. Did you understand where you gone wrong?
Yes, sir.
Yeah, okay. And yeah, tell me this exa. Please tell me, yeah, why? Because again, so
431, sir.
coming and seeing is 222. Watcha, okay.
431, sir.
Sorry, please tell me again.
431, sir. The 1AF base 16 hexadecimal to decimal.
Acha,
4.
431. Yeah. This is the answer.
The
Everyone
ideal
got the same?
would be 432.
Everyone got the same number?
The 16 square will be 256, and
Okay.
in the end it would be
Hmm. Yeah. This will be 16
and
plus
f would be 16. So 6 plus 6 would be the end number should be 2. So it's 432.
432. Please check. 1 cross 16 threes. Yeah, this is the one, right? 0, 1. Sorry. 0, 1, 2. So this will be 256 plus
Plus 160.
A into 16 plus 16. So what this A means? 160, right? Now final number will be
Yeah.
250 plus 160 plus 16.
Plus 16. So end number should be 2. So 432.
Sir,
Sir, value of f is 15, no, sir?
256.
F is 15, no?
so the last one is 15, sir. 16 power 0. So 15 will come, sir. F is 15.
16 power 0.
Yeah, exactly. Yes, I was wrong. See, sometimes I also maybe
Okay,
do
okay.
wrong.
I got it.
0,
I
1,
got
2.
it wrong. Right. Thank you, sir.
So
And
this will
thank
be
you to the
1.
other person.
Yeah, 160. So these are the things we'll do the mistakes. Most of the things. So we'll lose one more. So now the overall will be 431. So small things only. We in that tension or in that hurry, there is a chance to lose. So my suggestion that don't do practice on this and never do mistake on this. So I'll tell you one trick. Like every batch, I used to tell the same trick. See, suppose like if you know one question, like you whenever you saw the question, you feel that how you know, how you can do, you already know. That means by seeing itself you will be knowing, right? So then you need to take care of one thing. You need to cross check your answer twice. Why? Because wherever we already know, because of that confidence we'll do mistake there. 90% will do mistake there. Any somewhere in the calculation, somewhere in like manual errors, it possible. But wherever you know, you feel that yeah, I know this, I can do it. So there only you'll do the mistake. So cross check your answer twice. So that is a suggestion I used to give for every batch. So that's why any even it let it be the hurry you have, how many time you less time you have. Why? Because whatever you write on the paper that should be correct. That's why cross check twice. You even it is a favorite question, even it is your favorite thing. Cross check twice. Okay. Anyhow, which one is like some question you don't know? Definitely you will put mind on there. You will not be confident over that. So you will be very careful on that anyhow. So wherever you will not careful, because these type of questions will not be careful. So be careful when you are doing your already known questions. Cross check your answer and complete procedure twice, even though it is correct. How much time it will take? Just 2-3 minutes. See, when you cross check, you miss this 16 power 0. So this couldn't be happen. Okay. Okay. Chalo. So we'll go for other. Anyhow, I'll give some questions for your practice for today, end of the this class. Don't worry. Okay. Chalo now. Okay. Shall I move? Okay. So now you have seen decimal to any number system. Okay. And also you saw any number system to the decimal number system. Okay. So this is the main thing. You need to remember anything, just what you need to observe. So if you want to converting any number to decimal, means you need to multiply that particular base like this, okay, using the base powers. This it is called as like base powers, 2 power 0, 2 power 2, 2 power 3, like this. Okay. So, and similarly, when you are converting decimal to any number system, means you have two types, like division method and multiplication. If it is a fractional number, then you will go for multiplication. So like this. Now let's see how to convert an octal number to binary number system. Octal number to binary number system. Okay, let's take an octal number 216. This is my octal number of base 8. And if you see, if you are converting to binary, let's see what is the power of the octal number. Base of the octal number, it's 8. Okay. So where you are converting to the binary. So what is the base of the binary number system? It will be 2. Okay. In order to equate these two bases, how do I need to equate? I can equate like this. So 2 will be equals to the 2 power 3. Okay. So I can equate like this. So that means when I am denoting an octal number in terms of binary, so I need to use 3 bits. Why? Because using 3 bits, I can indicate up to 0 to 8 using 3 bits. I am telling 3 bits. So that's why in this I got the idea. So if any number I can denote with 3 bits, so it will become as a binary number. So let's see. I'll go for one by one. So 2 1 6. So 2 I need to denote with 3 bits using binary. Okay. How to define this in the binary? So we have a code 8421. So in this 8421, how you used to define the binary number? How you used to define the 2-digit like this: 0 0 1 0, right? So but I want only 3 digits, so I don't want this. So I want only this. So my 0 1 0 will be 2 in the binary, and similarly 1 can be generated as 0 0 1, and similarly 6 can be generated as 1 1 0. So if you write the complete number 0 1 0 0 0 1 1 1 0. So this is a complete binary number, octal number which is converted into binary number. And similarly, if I tell 1F6, convert hexa to binary, that means base 2. Okay, so similar procedure, but how to define? See, if what is your base number is hexadecimal, so you are converting into where of binary base means what? 2. So if you want to equate this, how can I equate 2 power 4? So using 4 bits I can denote my hexadecimal number. So like this, 1F6. So 1 can be denoted as 0 0 0 1. Why I am using 4 digits? Similarly, F means 1 1 1, 15. Okay, and similarly 6 means 0 1 1 0. So combine these all, this will become as binary number. This will become as whatever the hexadecimal number in 1F6, it is in binary. Now see, when you want to convert now hexa to octal, okay, let's take one example. 2CD. This is my hexadecimal number. So I want this number in base 8. So what is this is a D, not 0. This is D. Come on, D, 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 D. Okay. So what is the best method that I can convert? So what I will do, I will convert first hexa number into binary. Okay, and then after from binary to octal. So this is the best way you can able to do with best way. This is the best way. So what is the hexa number here? Let's see, 2CD, and 2 can be denoted as in the binary using how many digits? We need to use 4 digits. Why? Because it's a hexa number. So how can I 0 0 1 0? 4 bits I'm using. And what is C? C, what is C? You need to see A, B, C, which is 10,
13, 12, 12.
11. Yeah, that's what I'm going to tell you now. See, this is also one more mistake we'll do. First, write it down. Don't get like directly. It may chance to we can do wrong. So write down it. A equals to 10, B equals to 11, like this. So C will be 12. So how can I 8 4 2 1? So I can denote the 12 as like this, 1 1 0 0. So this will be 1 1 0 0. And D, while coming to D, what is the D equals to? 13.
1101.
Yeah, 1101. Done. So if you want to write continuously 0 0 1 0 1 1 0 0 1 1 0 1. So this is a binary number. So now what I need to do? I need to convert into octal number. So how can I use to convert? Using how many numbers I need to use for octal? 3 bits. So just point your 3 bits like this from left to right. So using these 3 bits, and these 3 bits. Okay. So if you write these 3 bits, what are these number? 5, 1, and what is this? 3, and what is this? 1. So the overall octal number will be 1315. So this is my octal number. So what I did, first I converted into the binary and then I converted into the octal, like this. Okay. Similarly, octal number also. If I give octal to hexa, if I tell that how to convert octal to hexadecimal, same. Convert the octal number into the binary and then binary to the hexa. Yeah. Okay. Now I am going with one number. Shall I move? 1 minute. Yes. Now let's see. 1110 11.0110 Convert this number into hexa and octa. Yeah. Please tell me. Yes, yes. Come on. So what is that number? 111 0 1 0 1 0 1 1 dot 0 1 1 0 0 1 1 0. Yes. So you need to go from here from left to right. And what about after decimal point? Right to left. Like this you need to go. Yeah, now tell me. So I need to convert into hexa. So how many bits I need to use? Come on.
4.
Yeah, 4. Please tell me that. Please tell me. Come on, come on. 2 minutes. We have time. 1 or 2 minutes.
3AB.
Okay. Same. Everyone got the same. Okay.
3AB dot 66.
Okay. Okay. Different answers. Okay. I'm pointing. See. 4 and these 4. And what about these? Only I have 2 bits. So you need to add zeros. Array, how can I add 2 zeros here? 2 zeros here. So the number will be here what? 3. And what about here? 1010 will be what? 10, right? Anyone? Here it is 8. 2, which
Yes,
is
sir.
10. So 10 means, how can I write? A.
A.
And next, and what about next here?
D.
1011 D. Okay. So 3AD point, and here 4, 4.
B, sir. B.
It's B.
Yes, sir.
Okay, let's see. 8, 2, 1, right? So 12, 13. Is this 13, right? 8, 4.
11, sir. 11. 11.
11, 11.
Oh, great. So this will be B. Hey, you are sharp here. Everyone got sharp. Yeah. Now see, what about here? This will be 6, I guess. And this is also 6. So the complete number will be 3AB dot 0.66. Yeah, similarly come here. Octal number. Yeah, tell me fast. Write down here neatly 1, 1, 1, 0, 1, 0, 1, 0, 1, 1. See, I can do wrong. Please, you need to help me on this. 0, 0, 1, 1, 0. Come on. 3 here, 3 here, 3 here, and 0, 0 I will add. So this is also 3. And coming here, 3, 3, and 3, 0 I will add. This will 3. And what about this? 1. And what about this?
1653.314.
Yeah. Dot 3, 1, 4. Good. Okay. So like this, you need to define when you got such number like this. Okay. Fine. Okay. So I'll give one examples. You can do it by today. Please note it down and we'll go for next topic. Yeah. Shall I move? I'm moving whenever you want. Please tell me. I'll bring it back. Okay. Please write the practice questions. Practice questions. PQ. Okay. Yeah. Someone want to? Any doubt?
Yeah, sir. Can you do one second after, I mean, before what you have done? Can you show me that once?
Yeah.
Yeah,
Okay. Shall I?
Yeah.
Okay. Convert this into 16, 8. Okay. And next, yeah, why can't this is also binary. And coming to next, sixteen, 2, decimal, binary, octa. Okay. And yeah, this first one, Second one, yeah, I'll come back, don't worry. And here, third one will be convert into octal. Yeah, I guess it's fine. Everything will cover.
250.
25D, again it is D. Arey yaar, I was writing with mouse now.
Okay.
D. I cannot able to write D. See, let me practice D. D. No. Arey, it's going. D. Okay, anyway, I'll tell you
Try
what
to
is
input
it.
the text.
So is this fine? Shall we move to next? This is fine. Yeah. Shall we move?
Yes, sir.
Yeah. Okay. Hmm. Okay. Now let's see. Okay. So with these number systems, we have done with the number systems. Now suppose if they ask, like if anyone asks 1 3, okay, 1 3, convert this. I didn't give what is the base of this. Convert this. क्या बोलना? How can I? Let it be. Okay, later on you can discuss with this conversion. Yeah. Please tell me what is the base will be. What is the base of this particular number will be?
4.
4.
Hmm.
Greater than or
So I
equal to.
already told you that x will be greater than or equals to 4. Okay. Um, and similarly, if I ask before going to tell this, everyone should write these all numbers. Otherwise, we cannot. It won't be clarity. Decimal. Please draw the table of this, and you can write down these all numbers: decimal, octal, hexa. Hexadecimal. Hexa means just it's a hexadecimal. So write down these all numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to you can write down 20. Okay, I'm just writing on 11. Okay. So this will be a 0 only. Yeah, 1 and these all same. 2, 3, 4, 5, 6, 7, 8, 9, 10, and this will be 11, and so on. Okay, you can write down. So what about octal number? You will have here same 0 and same 1 up to where? Up to 7, 4, 5, 6, 7. Okay. Yeah. Now please tell me the octal number. How to write this octal number? 8. How to write this 8 number? Yeah. Please tell me anyone.
1A.
1
A.
1A. Check it. Why A came here? It's an octal number.
Oh, sorry, 10, I guess.
Yeah. So this will be 1 0. So in order to indicate this, how you will do? Directly convert your decimal number of base 10, convert into the octal. Simple. So if you convert, how it will be? 8. So 8 ones and the remainder will be 0. So what the number will be? 1 0. Right? So similarly 9. Yeah, please tell me the 9.
1 1.
Yeah, 1 1. Okay, next. Go on, proceed. 1 2. Right?
Yes, sir.
And 11 will be 1 3. Right? So again this will be go on up to where? 1 7. What about after that? It will be again 2 0. Again 2 1. 2 2. So on like that. So when you are exceeding your 7 bits, the number of bits will be increased for the octal. For every 7 bits, number of bits will be increased. Again here 8 to, I guess it's 11, 12, 13, 14, 15, 16. Up to 8 to 16, again it will be 2 bits, and after 16 it will be 3 bits again. Not 3 bits, sorry. Uh, the 2 0 will be become, right? So there is a chance that your number of bits will be going to be increased in the octal number, right? If you see in the hexadecimal, same 0 1 2 3 4 5 6 7 8 9 10, sorry, A B C D, so on, right? And what, like, if you want to define a number 16, yeah, so what is a hexadecimal number? How you will define in the 16?
1 0, sir.
1 0. Again 17,
1 1.
1 1,
1 1 1
1 2,
3 1.
1 3, 1 4, so on up to where? 1 F. So after 1 F, what it become? It will become as 2 0 again. 2 1 2 2 2 3 2 4 2 5. Again it is what? 2F. 2 0 to 2F. Again after 2F to, again after that 3 0 to 3F. Okay, again 4 0 to 4F. So on up to until FF. Until FF, right? So in order to become the 3 bits, what is the next number will be? So it will be like this. Again it will be 1 0 0. After FF 1 0 0. So and so on, the numbers will be continue. So that's why your conversions will be required, like in which particular number systems, how to define. So that's the main. Here you will understand the application of the conversions, like where to where, how to convert. Okay. If suppose if I tell, yeah, 325. There is a base number. Okay, decimal number. Sorry, there is a decimal number. Indicate this number in base 4. Yeah, please do it. 325 decimal number. Indicate this number in the base 4. Come on, how will you do? Decimal to any, I told. I didn't give particular expression. Any base. So that might be any base. So I am taking base 4. So how will you do? Simple. 325 divided with 4. Tell me that answer. Anyone done? Oh, there are so many questions. Yeah, please
One more.
speak out. Okay. So whenever you sending message, now please just tell me or anything. Speak out or I'll come and see. Yeah, please tell me answer. Yes, please.
11011.
1-1.
1.
Your audio is not clear. 11011.
Yes, sir.
Yeah, okay. Are you sure this is correct? I'm not cross-checking. Everyone got the same, I guess. So this will be the base of 4. So what with this example, what you try to understand, not every time your base will be only 10, 8, 16. Not only those 4. There is a chance of any number of base. So you need to be ready of that. Like these type of questions. Okay. Sometimes they can ask like, see, how to write a 16 base 16 a 16 number in terms of base 5, in terms of base 5 in terms of base 5. So you need to convert and see, you need to convert and you have a regular method. That's not a problem. If you small shortcut, if you want, means I can give you base. Suppose if I take base is x and 1, just take these two numbers x and 1. So I'm taking x equals to 5 here. That's why I took 5 and 1 here. Okay. Now see 16. How can I convert into like 16 means 5 threes. 5 threes 15, right? Yeah. 5 threes and plus 1. So this will be 16. So 31 will be the my base 5 number. 16 in decimal will be 31 will be the my base 5 number. So how I got? First I need to write base of my that number and just 1. Okay. So I need to equate the 16. How to convert into 16 means with multiply 5 threes 16 plus 1 ones 1. Suppose this will be any number, this will be multiplies again 1 1 jar like that. So that directly it is a 31. Okay. So let's see. Let's take 13. Can you denote with base 4? Yeah. Okay, this is a decimal number. Denote this with base 4. Yeah. Please do it fast. How you will write? Again 4, 1. So tell me the number. Yes, please.
Same 31 it will come, sir.
31.
Same 31
Yeah,
will get.
same 31. 4 3 is 12. This will be 1. Okay. So same 31 again here. 31 of what? Base 4. So when you have a small digits like this, you can directly use this shortcut. Like what is the shortcut? Only simple base and 1. So using that base and 1, you can do it. Okay. Yeah, this is one more shortcut that we have. And or simple method, like you can go directly conversions. That's not our problem. Like this, how we went for the conversion. So this is also okay. Chalo. So this might be the possibilities, like you will get many number of questions on this. Like different questions means these are the questions you will get. Like base any number out of these four numbers, like base 6, base 7 possibilities there. So you need to be ready with that. Simple, any of the base means, suppose there is a base x means the numbers will denote in between are 0 to x minus 1 number. That's it. So x will not include here. X will not include x minus 1 number. Only using these numbers you need to define this particular number. That's it. And yeah, you will have one website, digital. 1 minute, let me open it. I'm not sharing your screen for 2 minutes. I want to open here. So we have some practice questions here, 100 questions. So every time we need to, after completion of the topic, you need to do practice of those questions. I lost that link, I guess. Oh, come on. Yes, I got it. Okay. I'm resharing screen. Yeah. Tell me you can able to see or not. I'm giving link here. These all
Sir,
questions.
we are already get the link, sir. Yesterday night.
You already got the link? Acha.
Yes, yes, from Srinivas also.
So, yeah, okay, fine, cool. So here we have a question number 14. Question number 14. Okay. Please do practice of these questions. Like how many you can able to do, you can do it. Still, I will discuss this. Don't worry. Okay. Okay. So we'll move for next topic. Question number 14. You can write down here. You can write down anywhere. Question number 14. 1-4. Yeah. Okay. Now let's see. Logic gates. Logic gates. So in this digital, we have the logic gates. First initial logic gate is AND gate. Or not. Yeah, before going to this, anyone is there from electrical background?
Yes, sir. I am Samshir.
Anyone is there?
Yes, sir.
Your
Samshir.
voice is not clear. Acha, only one. Okay, I'm coming there. Let me. Please send the message. How many people are from electrical background, so that I can count it. 9 nor XOR X nor. So these are all logic gates we used to discuss one by one. In a short form, we'll discuss what is the each logic gate does. Yeah, how many people? Okay, one person. Okay, Mo Muhammad. Acha, Muhammad, right? Okay, okay, fine, no problem. Now let's see. We'll go by one. Yeah, AND gate. So first, it's an AND gate. The symbol first. The symbol of the AND gate is this. A B. I am taking A B. You can take any of the alphabets. No problem for me. But I used to write like this. Okay. This is the symbol of an AND gate. If you want an expression of the AND gate, means output Y equals to A dot, means multiplied, dot product B, Y equals to AB. This is an expression. Okay. So if you ask truth table A, B and Y, so what is this? We are, and let's see here how many inputs I'm taking. Two inputs I'm taking. So how many combinations does I can form using a binary bits 0 and 1? How many combinations I can form? Four combinations. So what are those combinations? So those are 0 0, 0 1, 1 0, 1 1. So these are four combinations I can able to form. So now let's see what is the output. What will be the output? So the 0 dot 0, okay, which is nothing but 0. So 1 dot 0. What is that? 0. Again 0. And again it will be 1. 1 dot 1 will be 1. Okay. So if you speak in the electrical format, so it will be like this switch. It will be like this switch. Okay. Where this is the input, this is the output, where A, B. So when one of the switch is closed, so will you get the output? No. Both should be closed. Means both should be on, right? So then only you can able to get the output. So that's what here the logic is. So what is the logic here? When both the inputs are 1, so then only your output will be the 1. Okay. So we'll speak about more than 2 bits. First of all, we'll speak here about what with the 2 bits. What it happens with 2 bits. Okay. And similarly, OR gate, or here A B and Y. This is the expression and symbol of the OR gate. And while coming to expression y equals to A plus B. A plus B. So while coming to truth table A, B, Y, 0 0 0 1 1 0 1 1. So the output will be 0 and this will be 1, this will be 1, this also will be 1. So any of the input is 1, so output will become as 1. So this is the main logic. Catch this point. If any of the input is 1, output will be the 1. So the circuit will be like this. So you will get the output here. I gave the wrong. No connection will be here. Okay. So if a switch is closed, any of the switch is closed, so your output will become 1. Right? Closed in the sense on. Any of the switch is on out of this, so your output will become as 1. So like that. And finally, NOT gate. The symbol of the NOT gate is okay A and output Y. The expression of this Y output will become as A bar. That means invert of A. So if I write the two table, so how many combinations I will have for one input? I will have only two combinations. So if I give 0, output will become as 1. If I give 1, output will become as 0. Okay, this is about NOT gate. And next, NAND gate. NAND gate. So just opposite of AND. Okay, just opposite of AND gate. So that means symbol will be what? This is the symbol of an AND gate. Just opposite. That's why I gave bubble here. So this is the symbol of NAND. So A, B, and output Y. So expression, the output expression can be written as A dot B whole bar. Okay, and next the truth table, if you write A, B, output Y, so 0 0 0 1 1 0 1 1. So what this will become? So this will become as 1 1 1 and 0, just opposite, right? So if you see the truth table of AND, all zeros, it's just bar, right? Output bar 1 1 1 0. So whenever you have both the inputs are on, then only then output will be 0. And next, NOR gate. NOR. Just again, this is the invert of OR gate. Invert of OR gate. Now let's see the symbol. If we want to see the symbol of the NOR gate means.
What is the circuit of NAND gate?
Sorry.
Circuit of NAND.
Invert of. I didn't get your point. NOR gate is the invert of OR gate.
The switch diagram of NAND gate, like how NAND works.
Your voice is breaking actually. And output expression will be A plus B. Again it is bar, right? And if you write the truth table for this, A, B, output Y. So again it is 0 0 0 1 1 0 1 1. And come here, So what this will be, if you see OR gate, so what 0 plus 0 0, right? So similarly, if you go here 0 plus 0, it will 0, and inverting of the output, so it is 1. Okay, and similarly this 1 and output will become 0. This is also 0, this is also 0. Yeah, these are about NAND and NOR. These two gates, will call it as universal gates. Why? Because you can realize any of the gate using these two gates. Using these two
Yeah,
gates.
am I audible? Hello.
Yeah, now you are audible. Yeah, please tell me.
Yeah, what is switch diagram of NAND and NOR? Like you just showed for AND and NOR, right?
Switch
How it
diagram.
works? Yeah, can you just scroll up?
Acha, you are asking this switch, right? Switch. Just it will
Yeah,
be opposite. Output you will have an inverter, like uh, in a क्या बोलता है?
I know.
Like output, huh?
At output we will be connecting inverter, right?
Yeah,
And
yeah.
how it is done.
How exactly?
Take it parallel, sir.
Ha.
Here, AND gate is the series, no? NAND gate was the parallel. Take it
NAND gate will be the parallel. Yes.
across voltage, it is parallel.
Sorry, I was doing wrong. Okay, I'll show you. Don't worry, I'll show you just now. Don't worry, I'll show you exact connection. And yeah, these are called it as universal gates, and this would be yeah, we can realize any of the gates using these two gates. That's why it is called it as NAND universal gates. Okay.
Excuse me, sir.
Yes, please.
Uh, Sir, for AND gate, the switches are in series with the load, and for NAND gate, the switches are in series and parallel to load.
Yeah, you need to do such connection. I'll show you. Don't worry. In switches, I'll show you. Don't
Yes,
worry. Just only three I have showed you, just for your like initially how they are identified. With this, they have got the idea. That's why I showed you just for the three. Okay, later on I'll show you. Don't worry. And for XOR, you will have first the symbol of the XOR will be like this. This will be the, and inputs are A, B, and output is Y. Okay. And while coming to the expression of the Y, A, see here, this would be the expression will be this like this: A XOR B. And so we have four combinations again: 0 1, 1 0, 1 1. And here the logic will be the XOR is whenever you have the same inputs. Whenever you have the same inputs, so the output will be 0. So the output will be 0. That means this one will be 0. 1 1 will be the 0. More than 2 bits we'll discuss. No, don't be hurry that. And next, if it is a different bits, so the output will become as 1. And we'll also discuss that switch diagram. Okay. Yeah. And this is the basic truth table for two input XOR gate. Okay. And similarly XNOR. The symbol will be A, B, output Y. So the output expression will be A X naught, like this. B, okay. And the truth table will be A, B, and output Y. 0, 0, 0, 1, 1, 0, 1, 1. So here it's just opposite. Whenever you have the same inputs, your output becomes 1. So the remaining different inputs, you'll have a output will become as 0. Okay. Okay. So these are, don't worry, I'll also tell that switch diagram. Anyhow, I need to come again back with a more number of 2 bits, right? So then we'll discuss on that switch diagram. Don't worry that. Okay. Now let's see, when you have, these are the more logic gates that you have. So mostly we cannot use directly these logic gates in the real-time scenario. Okay. Sometimes we will use, sometimes we cannot be used. We don't want to use that. We need to convert in certain format. So okay. In the real time, like we need to know how to convert into the multiplexers. So any of the gate, how to design in the form of multiplexers. Then multiplexers to latch up to FPGAs, program logic arrays. So like that, we'll go on like that. Why in terms of power and in terms of area wise, we will convert into mux and we'll convert into the latch ups and we'll proceed in a real time scenarios. Okay. So that's why it is important to know how to convert into muxes. Means there is no chance like in the electronics can be asked in the form of electrical format. Means it's not a problem for you, but you should know definitely on how to convert on muxes. So let's go with mux. Before going to that, you need to know what is a mux. Two into one mux. 2 into 1 mux. Okay. Yeah, be careful here. Listen for 2 minutes. 0, 1. Output Y. This is selection line. And this will be the A. And this will be the B. Okay. So when multiplexer topic comes, why it is 2 inputs, and we'll also discuss that. Now let's see. Just I am taking only 2 inputs and 1 output. Every time the mux will have only one output. So the complete expression that you will have 2 power n into 1 mux. That means when n value is 1, so it is 2 into 1 mux. If n is 2, it is 4 into 1 mux. N is 3, 8 into 1 mux, like that, so on. So we'll go into depth in that multiplexer topic. I don't want, at this point we don't want. So only I need 2 into 1 mux. So let's see how to write the expression of this mux. Okay. So output Y equals to selection line. Yes. When S equals to 0, if I give 0 as this input for this particular, A will select here. The selection line A will select here. So it will be written as A, and Y, where by telling what I told, when S equals to 0, right? 0, right? So I gave S bar. Similarly, plus when s equals to 1, which selection line will select? One selection line will select, second one. So which is nothing but B. This is clear. Now in the same way, if I ask like this, A, B, S, yeah, output Y. So I will give like this. I'll give 0 here. I'll give X bar here. Yeah. Please tell me expression now. Can anyone tell the expression of this?
S bar X and SX bar.
This is 0. So S bar into 0 plus S X bar. Right? This is fine. So if I ask, I need to open a new window. Yeah. So if I ask like this, please tell me now. Yeah, please tell me expression of now. Y, output Y expression. Just tell me expression. Later on you can simplify it.
X bar and 0.
X
X
bar
bar into 0.
into
X bar
0
X. X, sir.
Plus X.
Bar into 1, sir.
plus X into, just tell me the
1, 1,
initial
1,
expression.
1,
1.
1.
Is this correct?
No, sir.
Everyone agree?
No, sir.
So this is the drawback of this. So Y, when X equals to 0, in this marks I gave in this format. This is a 0th line. I have indicated here. I indicated like this. One line is here. So whenever X equals to 0, which one will select? 0th line will select. So when X equals to 1, which one will select? This particular line will select. So the expression will be like this. X bar, that means when X equals to 0. So what is the 0th line? 1.
1,
Plus X into
0.
0. So this will be the expression. So this is the main point you need to remember. Okay. So these indications are important. So when you in the hurry you write like this. Like everything was correct, like you wrote like this. So when the person who was evaluating this answer, he will feel that he will not understand how you wrote. Means it's incomplete. This is an incomplete question, incomplete answer. Sorry. So you need to indicate the bits of every line, which respective bit it is. Okay. Even the selection lines also it will be indicated as 0, like this. So later on we'll go into discuss, and we'll also see that what is this? all the logic gates using muxes. Yeah, all the logic gates using muxes, and you, as you told, these electrical circuits also. I can directly draw it now, but if I need to draw it at myself once, then I can draw it here. Okay. So these are the things that we can cover it up today. Uh, Tomorrow we'll speed it. Today is a basic class, that's why I went slow, and also only basic things we have deal today. Uh, yeah, for today we can close. From tomorrow we'll discuss all logic gates with using muxes, and also all the logic gates with more number of inputs, means more than 2 bits. Yes. Any doubt you have except these things, or any other things you have doubt, whatever the till now we have discussed today, you can ask me. Remaining guys, like, thanks for them. Yeah. But from tomorrow we'll end up the class by 10 o'clock mostly. Uh, Today is the first class, and I also got some work, and that's why I need to go. So it would be mostly class will be like 7:30 to 10 o'clock. And 7:30 is fine for everyone, or so can you repeat 2 into 1 marks again? Yeah, please tell me. Where is this? Yes, here. Hmm. Yeah, in order to understand you clear, I'm going for next. This is X, where this is, I'm taking M. This is M. Okay. 0, and this will be A bar. Okay. If I write output expression Y, what I need to see in the marks, first of all, you need to see when x equals to 0. Selection line is x. The variable I gave, name it as x. So when x equals to 0, which one will select? So whatever the number that you gave, suppose some people can give like this. Some people can give like this, 0, 1. Okay. So in this case, when x equals to 0, the 0th line, this will select. And it gives whatever the input here, it directly gives your output, right? So similarly here, when x equals to 0, which one will select? This particular 0th line will select, and whatever the input you have, you'll get the output. So that means if I write like this, when x equals to 0, that means x bar, and what will be my output? Whatever the input of 0th line, that will be my output, A bar. Okay. And again, x when x equals to 1. So when x equals to 1, so similar, this one selection line will select, and that will become as M. You can ask me, sir, why, if you still didn't get the clarity, I can go you for here. I have 2 selection lines and 4 inputs, right? So in this case, this will be 0, 1, and I'll give like this, 3, 2, 1, 0. Now let's see, when it is 0, 0, which selection line will select? This particular selection line. When it is 0, 1, 1 selection line. 1, 0, 2 selection line. 1, 1, 3 selection. It's simple like how the way you indicate. I indicate like this, reverse. I also here also, it reverse. So don't feel that every time this will be in the order. Sometimes disorder also. It would be like this. It may be like this. So it will be like this, 0, 2, 1, 3. So it's let it be anything. If once you saw the indication, you easily know. Here also like this. You don't remember the order. Just regarding these indications, easily you can know what when selection line is zero, zeroth line will select. When selection line is one, one selection line will select. This is about 2 into 1 marks. Okay, and this is about 4 into 1 marks. Don't worry, I'll discuss this slowly. And did you got your doubt, Gayatri? Please start it. One minute. I'm coming back. Who asked this question? Sujan, you got this? Still, if you have doubt.
No, sir, I got it.
Yeah, okay, thank you. What is your obligation? Daily it will be 70 to 10. 70 is fine. Okay. Can you start at 8, please? Acha. Kritika, acha. 8 o'clock you need. Yeah, Gayatri, I was working.